So I'm going to do a couple things. I'm going to go over some background slides about PJM, who we are and what we do, and then I'll go into a demonstration of an application that we built that we're using currently in our production environment. I'm really going to cover a lot. What I'm going to talk about really affects situational awareness at our company. So I heard this definition about situational awareness, which is knowing your surroundings, which is, I think, what Janice alluded to, but also being able to react in the event something happens that you didn't anticipate or plan for. So I hope, well, if I asked you individually, you'd probably tell me that you'd like to be this person on a kayak right now in the Atlantic Ocean. But I hope you're not this person, because he's clearly not aware of his surroundings, right? So let me talk about PJM. Most of you may not be familiar with who we are. PJM Interconnection, we're an independent systems operator. We run the grid in the Eastern Interconnection. We have three main responsibilities. We're primarily responsible for operating the reliability of our grid. Secondary, we're responsible for running energy capacity and ancillary service markets. And finally, we do all regional planning in our geographic territory. There's basically three parts to the electric grid. There's generation, transmission, and distribution. You're probably all familiar with distribution, right? Because that's the company you pay to get your electricity at your house. PJM basically coordinates and dispatches energy in that grid. We don't own any equipment. We don't own transmission lines. We don't have field crews. We purely just monitor the state of the grid and make sure that it gets from one point to the other. So, like I said, PJM is part of the Eastern Interconnection. We cover 13 states plus DC. We have roughly 960 member companies. We serve 61 million people. Our peak load in megawatts is just over 165,000. And the territory we cover includes 21% of the US GDP. So just to give you a little background, PJM has been around for a long time, since 1927. I have not worked there that long. We've expanded a lot over the years. Our most recent expansion was in 2013 on the southwest side. Up here, this is Pennsylvania, okay, and Kentucky is down here, and Chicago is all the way out here. So EKPC was our latest integration down here in 2013. It's a fairly large territory that we cover. And for the people that monitor the grid, our dispatchers, it's a lot of information for them to digest, right? This is just a picture of our control room, or part of our control room. The dispatchers have any number of tools available to them today. We have an energy management system. We receive our data over SCADA networks. The data is in real time every couple seconds from every installation. It's a lot of data. So they'll use their energy management system to look at one-line diagrams, to look at contingencies on the grid. They'll use OSI Pi extensively. In fact, most of the displays on our wall board here on our video wall are Pi displays. The Pi displays, for the most part, are tabular. They're charts, they're graphs. There's historical trends. There's some bar charts. It's all very useful information, right? I mean, we use this to help us with the current situation of the grid. But what we don't have today is something geographic in nature. Well, we didn't have it until we built this application. So you can imagine the territory as big as it is, with 13 states and DC. If we need to communicate with a transmission owner out in EKPC, or a generation owner or substation owner, if we need to communicate with someone, it's really tough to tell by looking at just Pi process book displays, where an issue is. And then tying that information together. What's the impact of weather on top of our map? What's the impact of transmission lines on top of our map? So this was our challenge. So what did we do to address this? And we've actually tried building a geographic map a couple times over the last, I'd say, 10 years. But the technology's come a lot further than it was even 4 or 5 years ago. So over the last 2 years, we've been deploying several different versions of DEMA. It's our Dispatch Interactive Map application. There's off-the-shelf applications, or an off-the-shelf interface from Esri GIS, which we do use in our organization, but we don't use it for DEMA. We decided to create a custom user interface because we didn't want our dispatchers having to remember where to click to find information, right? We wanted to provide as much information as we could at a glance, right? And there really aren't any tools off the shelf today that do that. So we had to customize a user interface. We did this, it's all HTML5 front end. Like I said, we use Esri GIS on the back end. We pipe data through OSI Soft and their and Esri's Geo Event Processor. We hook in data from Oracle databases, and we've even tied in some spreadsheet data. We get weather data from an external weather vendor. And the result is, it's actually surprising. I mean, the grid operators, the dispatchers have been very pleased. I mean, it's really helped them get a better understanding of the state of the power grid at any point in time. And this is all real-time data, by the way. All right, so let me get into a demo of the application. This is a video. It is in production today. Just due to the limited internet connectivity, I'm just running a video here. And I'm going to pause and play through this video. Okay, so give you an idea of what you're looking at here. If you remember in the earlier slide, this is PJM's territory, right? If you remember, this is EKPC. Kentucky is down here, Chicago's over here, Pennsylvania, and we go all the way down to Virginia. New Jersey is over here. Okay. The shaded areas, like this blue area, the purple area, the green area, these are our transmission zones. We have 20 transmission zones. The different colored lines represent different kV values. So the pink lines are our 765 kV lines. The yellow lines are 500 kV, and we go all the way down to 69 kV. So right off the bat, a dispatcher or a grid operator loads up DEMA in their web browser, since it's HTML5. They load up DEMA in their web browser, and they can see locations of transmission lines. Because this is video, I can't zoom in and out here, but you could zoom in. You could get down to a level where you would actually see substations in here. Okay. The other thing is we tried to really streamline the user interface. We have similar control bar that you would see with any other mapping application where you can zoom in and out and pan and tilt the map here. You can also use your mouse wheel or your mouse to control the map. All menu options are on the left-hand navigation panel here, and I'll show you how that works. Okay, so in the northeast part of the United States, weather on very hot days and very cold days can play havoc on the reliability of the power grid, right? So, on hot and cold days, people are either running their air conditioners or turning on their electric heaters, and it really raises up the demand for electricity. Can have a significant impact on the reliability of the grid. So, the one thing that they almost always monitor in DEMA is weather. They run this on the video wall, so they have the weather playing on the map. And we're pulling this data in from an external weather provider. We have a lot of features here that the user can look at, everything from, well, you'll see radar and temperatures we put on the map. You can also look at National Weather Service bulletins. We pull in lightning strikes and also some of the storm patterns we pull in as well. So the nice thing about this, as we see this play through, we're playing through 3 hours of history. and we're looking to integrate some forecasted data in here as well on ice and snow. We don't quite have that yet. But as we play through the history here, you can see that there's a northeastern pattern to this storm, which gives the dispatcher an indication that there is a significant storm, especially in this yellow shaded area, a significant storm system coming through here. So maybe this is something they should be concerned about. So now we're going to enable some more features to help them with their situational awareness, right? This is our line status or our line and outage window. This is real-time data that's coming straight from OSI Pi. It's reading, I don't know how many points, but it's a lot of points that we're pulling down here on a real-time basis, right? So it's going to give us an indicator of which lines on our grid are in and out of service. It's also going to give us a status. Are the lines planned out? Are they planned out but available to come back online? Is it an unplanned outage? Really important things that our dispatchers could really use. Now, to be clear, all of this information, like I said, is available in our energy management system through their one-line diagrams today. They just cannot see it geographically. So, okay, so what we're going to do here is we're going to enable the line status. And you'll start to see, notice there's different color lines, right? I talked about that previously, where you have pink lines are our 765 kV lines, and yellow is 500, and then you have other. Well, with line outages, any line that's out of service is white. Now this is in our development environment, so you wouldn't see this many lines unavailable in our production environment. But right off the bat, right, the dispatcher can see lines in and out of service. It gives them invaluable information. When we had the weather integrated with the map immediately, we did that in about a month. It didn't really take that long to integrate that data, only because we had an extensive GIS implementation already. It took us quite a bit more time to do the line outage integration. But once we did it, it really received a lot of attention from our operations, from our dispatchers and our operations support staff. So let's play through some of this data here. Now, what the dispatcher may have done at this point is he's probably looking at his EMS displays, which are telling him there's one-line diagrams. It's going to give him an indication of transmission lines that are in a service. It might tell him about some contingencies that are on the line or congestion. What he might be thinking about now is, can he find capacitors, reactors that he could call on to alleviate some of that congestion? Now, we don't have that data integrated just yet. We're working on it. But we did want to give the dispatcher the ability to search for substations, search for lines. And I'm going to show you how that works here. Because when they're interacting with their one-line diagrams, they have a name of a substation. Instead of moving the map around to find that substation, we integrated this search capability. So they can type, in this case, this is Mount Storm. They typed in the map repositioned on Mount Storm. I'm typing in a couple other substations now, and the map will keep repositioning automatically to include all the search results. So that's 3 substations I included here, 1, 2, 3. Now I'm looking for information about a transmission line because maybe I received a warning in my security analysis tool in EMS. I have a line name, and that line name is Mount Storm 2. I can't read that. 2 Valley, I believe. So now I've repositioned the map so I can see my impacted substations. I can see my line that's out of service that maybe is affected by a contingency. So what can I do about the problem? Now, in DEMA, we don't have the ability to turn things on and off. The dispatcher still needs their EMS, their energy management system, to actually change things on the power grid. This is really for informational purposes only. Well, on a cold day, gas is really important to PJM, right? A lot of generation owners are switching to natural gas. Natural gas is very prevalent in the Northeast now. So we're very much interested in the availability of natural gas and our generators' ability to run on gas, to find out if they actually have that natural gas. So what we've done is we've imported the location of natural gas lines, and that's what I'm doing here. I'm just going to turn on one of the lines that goes through part of PJM. This is a natural gas line in interstate. Eventually, we'll have a connection between the names of the generators and which gas line they're connected to. So at that point, they'll be able to filter on. They'll be able to filter on just gas units if that's all they want to see on the map. They'll be able to do that. Sorry, I'm rewinding here a little bit. Now I could take this one step further. Let's see. I could take this one step further. We have a program called demand response. You may or may not be familiar with it. The general concept is you have a company that maybe manufactures widgets. They have their own generator that can generate 1 or 2 megawatts of electricity, or they consume 1 or 2 megawatts of electricity, excuse me. They can shift their operations to the middle of the night because they're manufacturing widgets. So they might participate in PJM's demand response program on a very hot day or maybe a cold day where we need to reduce load or potentially cause blackouts, which we don't do. We'll send out a demand response signal. And those members that participate, in this case this manufacturer, he'll shut down his operations during that period of time. But the biggest challenge is, where are those units located? We have zip codes. We've always had it in a spreadsheet, but someone has to go into Google Maps or some mapping application to specifically find these locations. So we integrated that in the DEMA. So we have an area here of concern. I'm gonna take my mouse. I'm gonna lasso an area, and immediately it spits back. I can't read that. About 50 some megawatts of demand response that's available. It's organized by zip code and county, and it also tells you the megawatts that are available. We also get a heat map here, so I know any of the blue shaded areas have a low amount of demand response available, whereas yellow and red have higher amounts of demand response available. Okay, so that finishes my presentation. I'll let this play through here just so you can see it playing. That finishes my presentation. We do have plans to integrate a significantly more amount of data here, including generator information, how many megawatts units are generating. We want the users to be able to filter if they only want to see nuclear units. We want the users to be able to filter on that information. There's just endless possibilities with this application. So thank you very much.